Hello everybody. Today we're going to be talking about stoichiometry, and you're going to perform calculations of different types of conversions in stoichiometry this whole week. Now, stoichiometry means the measuring. So it's the relationship of the amount of reactants that you're using and comparing it to the products that are being formed in that chemical reaction. And of course, this is all based on the law of conservation of mass. Okay, so before you actually start your problem, you have to make sure a couple of things. That equation must be balanced. You need to identify what they're giving you and what is it that you're looking for. Then kind of create your roadmap, and then you can set up your calculation. Okay, so now this is your first template. Now this is in the included notes for today, and that PowerPoint has all of your templates for every single problem, so you might want to look at that. Okay, now whatever's given in your equation is always the first thing that you're going to write on your railroad track. Whatever this unit is, it doesn't matter what it is, whether it's moles, molecules, atoms, if you have mass, whatever that unit is, it's going to go directly to the bottom part because you want to cancel that unit and go to the next unit. Now, stoichiometry is not just changing the unit. Part of your unit is changing the chemical you're working with. So if I started off with water, but I want to know how it gave me, or what mole it gave me an oxygen gas, I'm going to have the water molecule down here. And these, anytime you have mole to mole, this number is going to always be the coefficient in that equation. Okay, let's go ahead and take a look at an example. Okay, here it says how many moles, so this is what I'm looking for, the moles, of KClO3 must decompose in order to produce 9 moles of oxygen is my given. Okay, so this is what I know. This is what I have. And here's my equation. Okay, so I like to kind of label my equation. I put a little question mark on what I'm looking for, and I'm looking for moles. That way I know where to stop. Then I always write what my given is. I have 9 moles of oxygen gas. These coefficients is what I'm going to be using. So I need to make sure that this equation is balanced. I have 2 potassium, I have 2 potassium. I have 2 chlorine, I have 2 chlorine. I have 2 times 3, I have 6 oxygen, and 2 times 3 is 6 oxygen. Yep, it's balanced. Okay, so now let's start with what is given. My given is 9 moles. Is that kind of hard to see? Let's do 9 moles. And it's of O2. So now, in order to cancel this unit, this entire unit must go down here. So I must have mole of O2. Now, what is it that I'm looking for again? I'm looking for the mole of KClO3. So I'm going to put mole of KClO3. Anytime I have a coefficient in front, these are going to be my moles. But anytime I have mole to mole on that conversion factor, this mole to mole right here, this comes from your coefficients in your equation. All right, so the KClO3, my coefficient is 2. And for O2, my coefficient is 3. This allows you to cancel out the moles of O2, so your answer is going to be in moles of KClO3, which is what you're looking for. Okay? Now, once you have all your numbers in there, everything on the top multiplies, so 9 times 2 is 18. Then whatever's at the bottom, you're going to divide. So 18 divided by 3. And this is going to give you your moles of KClO2. So grab a calculator. 18 divided by 3 is 6. Okay? And this is stoichiometry. So for right now, you're going to do just a little practice on going from moles to moles. But you know what? Before we do that, let's just do another example. Okay, so let's use the same equation, but instead of having a given of 9 moles, let's do KCl. What if I had something 7.50 moles of KCl? And let's go ahead and still look for the moles of KClO3 right here. You're going to have the 7.5 moles of KCl. That means that your mole of KCl will come down here at the bottom, and you're still looking for the moles of KClO3, so moles are going to be on top, KClO3, and this way you can cancel out the moles, and now you have the mole that you are looking for. Remember that a number without a unit means nothing. That unit is really what's going to tell you whether you're going to multiply or divide. So where you have what number is what's going to tell you exactly what to do, okay? So here, remember, anytime you have mole to mole, this means it comes from the equation, and it's your coefficient. So KClO3 is a 2, and KCl is also a 2. So because 2 divided by 2 is 1, 1 times 7.5, you're still going to have a 7.5 moles of KClO3. Now, once you know how to go from mole to mole, you can go from moles to grams, or moles to molecules, or moles to atoms, depending on what you're looking for. Remember, you must always go to the mole first. But you do have to change that chemical from the old one to the new one. Okay? Let's do a couple of mole ratios. Okay, now here's another example. If my equation is magnesium and oxygen, and it's going to give me a magnesium oxide. Now let's double check that these coefficients are correct. I have 1 magnesium, I have 1 magnesium. I have 2 oxygen, I have 2 oxygen. Yep, it's correct. So my coefficients are 2, 1, and 2. Remember, if you do not have to put a number there, it must be a 1. Okay, so what is my magnesium ratio to oxygen? It's a 2 to 1 ratio. Now, how can I use that? It's going to depend on what your given is. So if I'm given oxygen, then I have to have the oxygen at the bottom so I can cancel that oxygen. If I'm given something in magnesium, then I need to use this conversion because the moles of magnesium are at the bottom, and I'm looking for the oxygen. Okay, so let's give this a try. Let's say I give you, let's make this a 2.16. No. Let's make that, okay. Let's make this a 5 mole of magnesium. Okay. If my given is 5 moles of magnesium, and I'm looking for, let's say, oxygen, then my mole of magnesium must be at the bottom. And because I'm looking for oxygen, my mole of oxygen must be at the top. So this would be the one that I'm going to use. My magnesium has a coefficient of 2, So that's what's going to go here. And my coefficient for oxygen is this 1. So that's going to be my mole here. And that's your setup. This cancels your moles of magnesium, and your moles of magnesium are out. Now you have your moles of oxygen. Okay, so now all you have to do is everything that's in the top you multiply, everything's at the bottom you divide. So 5 times 1 is 5. 5 divided by 2 is what? Yep, you're right. It's a 2.5 moles of oxygen gas. And that's it. That's how you do the setup. Okay, if you have any questions, go ahead and ask me in Zoom, and then do the little exit ticket that you have in your folder.